Sup guys, today we're going to be doing a video on energy transfer. So in energy transfer there's I think 2 to 3 aspects in which you learn the types of energy transfer. So radiation, convection, conduction, with a focus on radiation. And so through that you learn concepts like the Wien's displacement law, the concept of albedo, the greenhouse gas effect. In this video, we're going to be focusing on the greenhouse gas effect and albedo because those parts typically get tested a bit more. Um, and I think those are fairly important concepts that require a bit of practice and just making sure that the explanation is clear. For concepts like Wien's displacement law, I do have a question for this, but I don't think it's that difficult of a concept if you understand the relation between temperature and wavelength. If you know Wien's displacement law, you know what I'm talking about. Ideally, before you do this video, you should have somewhat of a rough and decent understanding of albedo and greenhouse gas effect, because these videos are meant to somewhat serve as a tutorial in which we're applying our knowledge to specific questions. So let's get started. So the first question, very straightforward, is it's saying that 3 gases in the atmosphere are I, carbon dioxide, 2, dinitrogen monoxide, and 3, oxygen. And it's asking that which of these 3 are considered to be greenhouse gases. Now, believe it or not, it's pretty typical that people might not know all the greenhouse gases and mix them up. So this is basically a memory question, and you should know your list of greenhouse gases. So they are carbon dioxide, methane, nitrous oxide, CFCs, and ozone. Ozone's a bit debatable, but I say it is a greenhouse gas, but it's not one of the more well-known ones. And if you look at the options, straight up, you match up your list with the options. You know that oxygen is not as a greenhouse gas, and carbon dioxide is one of them. So I is definitely the right answer. This takes out. So hold on, let me get my pencil out. This takes out C, because I is not in that option. And dinitrogen monoxide is basically nitrous oxide or dinitrogen monoxide, so N2O. So that's also a greenhouse gas, which we wrote here as nitrous oxide. Sorry about that. Hence, the answers were I and II, and that leads to A. Hopefully, this question is basically a memory question. You list your greenhouse gases in your head, you match them up, see which one's not a greenhouse gas, and then, yeah, you answer the question. Let's answer the second one. This one's about albedo. One disclaimer. In albedo, it's pretty typical that it would consist of the use of quick math. So, and because you're not allowed to use calculators in paper 1 physics exams, you need to be a bit quick in your math. Although the math is very simple, just letting you know. So this is a sample climate model for the Earth, and this is very typical in paper 2. So I advise you to make sure that you have a good understanding of these climate models, because they do actually come up quite a reasonable amount. So just making sure you're understanding the difference between absorption and reflection. So not too difficult, but again, it comes to just practicing and being cognizant of what you're learning about. So we see that incoming solar energy, I assume from the sun, is 100%. So 90% of it is absorbed by the atmosphere and clouds. 51% is absorbed by the surface of the Earth. I assume if you guys learned about the greenhouse gas effect, good chance that this is what it's referring to. And 6% is reflected by the atmosphere, 20% of the clouds, and 4% reflected by the surface of the Earth. Basically, this question is actually kind of explaining you the concept of albedo and also the greenhouse gas effect, because it's showing you that not all in the 51% is mainly talking about the greenhouse gases which are located in the atmosphere of the Earth, and it's showing that not all of it is absorbed by it, whereas some of it either gets absorbed by clouds, or the other parts of the atmosphere are reflected just back into outer space. Hence why by the atmosphere, by the clouds, by the surface of Earth, to just other places, i.e. space in this case. Sorry for that, but I just was giving more context and just going beyond what the question is. Let's actually answer the question, which is, what does this model predict for the average albedo of the Earth? So already you see the keyword, sorry about that, albedo. that should raise an alarm bell that you should know what the albedo is. And so the albedo is typically a scale from 0 to 1, and it measures the ratio between reflected light in watts meters -2 over the incident light, so the light that's actually coming in watts meters per -2, or both of them are in percentages, decimals. The point is, the units cancel out, so you get some scale value between 0 and 1. So we look at the question. We should focus on the reflected light and the incident light. So you know that the incident light is basically 1 or 100%, right? And that's why I wrote incident light is equal to 1. But the reflected light is essentially the sum of what's been reflected. So by the atmosphere, by the clouds, and by the earth. So 0.06 plus 0.2 plus 0.04 gives 0.3. And to calculate the albedo of the earth, so it's the light reflected over the incident light. So 0.3, which is what we found here, and then 1, which is the incident light, which is equivalent to 0.3. You can convert this to percentages, to 30% over 100%, and then convert it to decimals, or just straight away convert it to decimals, up to you. And that gives 0.3, and that gives the answer of A. So again, this concept kind of alluded to the greenhouse gas effect, but it was more so testing your ability to just know the albedo, and read a simple climate model. An extension of this, maybe they could ask different questions, like asking conceptual questions in paper 2, but this question was a bit easier. Right, so the next question is also an albedo question, but it's a bit different this time. It's mentioning that the average albedo of glacier ice is 0.25, and it's asking what is the ratio between the power absorbed by glacier ice and power reflected by glacier ice. So power absorbed, power reflected. This is an albedo question, but it's not directly asking you to calculate the ratio, it's asking you to derive the quantities. So again, albedo is the ratio between reflected light, incident light, and they both have to be in the same units. So we're given that the average albedo is 0.25, so this can be written as 0.25 over 1 is equal to reflected light over incident light. And if we've been given that basically 1/4 of the light is going back somewhere, and if 1/4 of the light was reflected, that means 3/4 of it was absorbed, because at the end of the day, when light hits the surface, it can either be absorbed or reflected. So you subtract 1 minus 0.25, and that'll give you 0.75. So 0.75 is the light that, as a ratio, is the light has been absorbed. So to find the ratio between power absorbed and power reflected, we actually basically have found one of our quantities, and we know the other one. So power absorbed, 0.75. Power reflected, 0.25, and think about it as 75 over 25, so 3. And the ratio they gave was 3.0 over 3, and the answer is D. Apologies for the shocking. It looked like a B, so I just had to make sure. Yeah. Let's do the next one. So the next one is asking about how changes, basically testing again your concept of albedo. Actually, no, let's not do this question first. Let's do another one. I think it's more useful because it'll test your knowledge on the greenhouse effect. Sorry for that. I think it's just to help you guys, just to better connect the dots between albedo and greenhouse gas, and then do another question which is testing one of the two. So this is a straight up conceptual question about the greenhouse gas effect, and it's saying that the greenhouse effect can be explained by the fact that the infrared radiation emitted by the surface of Earth, A, is absorbed by the atmosphere and then re-radiated in all directions. B, raises the temperature of the upper atmosphere. C, is trapped by the upper atmosphere. And D, it's absorbed by the atmosphere and then all of it is re-radiated back to the surface. The questions, the options actually look pretty close to each other, but if you know the finer details of the greenhouse effect, it will definitely help you. So that's what I'll probably just quickly do right now. So the greenhouse effect, it's a process at the end of the day in which the Earth's atmosphere, which comprises of the greenhouse gases that I mentioned, basically traps the sun's heat. And effectively what it's doing is that it's absorbing infrared radiation. This is good because it's actually warming the Earth, because at some point the greenhouse gases release the trapped heat, either to other areas or back to the earth, and so it's warming it. But it's bad. So this is where you guys need to become aware that because people are like doing more industrial processes, it's actually leading to more greenhouse gas effect. And so because there's more and more greenhouse gases being generated, there's the amount of warmth that's actually needed is exceeding it, and so that's actually increasing the overall temperature of the earth. So to give a very quick model, sorry, I didn't want to get a picture from Google. I thought it'd be a bit better to just explain it using a very rough sketch. So think about it, this is the sun. It's emitting its rays to the atmosphere, and this atmosphere consists of greenhouse gases, and so it's trapping it. However, there comes a point where there's radiation in all directions. However, yeah, some of it can be back into the earth, some of it can be back to the space in other places, but it's not all. Not 100% of it is radiated back into the earth. Rather, it can be radiated in other places. It could, like as I mentioned again, it could be reabsorbed by other GHGs, go to outer space, or etc. And the key thing of knowing is that it's not just going to the earth, rather it's going into other directions as well. So that brings me to the options that we're looking at. If you look at B, raises the temperature of the upper atmosphere. That sounds true, but if you actually think about it, if the greenhouse gases are at the upper of the atmosphere and they release the heat from the sun's rays back into the earth, that's actually heating the lower atmosphere where the earth, the people, and everything else are, but it's actually somewhat cooling the upper atmosphere because the energy is leaving from a hot place to a cooler place, right? So technically B is not completely true because of one word, raises. If it just said raises the temperature of the earth, that's true. C is trapped by the upper atmosphere. That is true, but if you actually just look at the other options, it seems a bit short and it might not be the best answer. So you'll definitely want to come back to it, but it might not be the best answer. D, it's absorbed by the atmosphere and then all of it is re-radiated back to the surface of the earth. The key word here is all, which is not true. As I mentioned, it's not just going to the earth. And so if you look at A, it's absorbed by the atmosphere, true, and then re-radiated in all directions. This is the key difference that I think makes it a better answer because it's actually true, and it's basically explaining both the fact that it's absorbed and also that it's re-radiated in all directions. That probably makes A the better option. I think C could also be wrong because trapped is not necessarily maybe the right word, but I think the idea which it's going at is definitely correct. But A is a better answer ultimately. Hence the answer is A. Now let's go back to the question about this one. Sorry for that. So it's saying that changes in the climate are leading to a reduction in ice cover on Earth. Which of the following describes for Earth the change in albedo and the change in the rate of energy absorption? If you look at the two, they're ridiculously like interrelated. They're actually asking you the same question, but in like a different way. So again, the hint is ice cover. If the ice cover is reducing, I think you may know that it actually has a very good albedo, and what I mean by good is that it has a low albedo. And so if that's gone, the stuff below it, i.e. water and land, they will have higher albedos, and so they'll be more prone to actually absorbing it. So as a result, if the reflected light is decreasing, if the ratio between the reflected light and the incident light is decreasing, that means that the albedo is also decreasing as well, meaning that more of it is being absorbed. And so if more of it is being absorbed, before I go to that, let's look at the second part, which mentions that the change in rate of energy absorption, it's kind of alluding to emissivity, which I don't think it's a direct property, but it's definitely very similar. I'm just kind of connecting different parts of the syllabus. And so the logic behind this is that if your albedo is decreasing, aka that means more light is being absorbed, so more light is being absorbed, and therefore the rate of energy absorption is certainly going to increase, right? Like if you're absorbing more heat, the rate of absorption will definitely increase. So therefore, the albedo is decreasing, and the rate of energy absorption is increasing. Sorry, Let me reiterate that. The change in albedo is decreasing, and the change in rate of energy absorption is increasing. Hence, the answer is B. Sorry for that. And now I'm going to leave you with two questions. The first one is that one of the trickier ones of albedo and global warming, but I think you can get it right. I'll give you 6 seconds to read the question. So this, I think you need your good knowledge of just albedo, greenhouse effect, and just your general knowledge. It's a general knowledge question, but it's definitely like an applied general knowledge question, so you have to be careful of which options to pick. Now this one is actually quite different to what we've done. It's not relating to albedo. It's more so relating to the concept, overall concept of radiation. And you could probably take a quick read. So you'll notice that keywords: intensity, wavelength, surface temperature, not just temperature. This is basically alluding to Wien's displacement law. And what happens is that we know that there's a form of energy transfer is effectively radiation. And the way it works for it to be effective is that it's basically radiating all that in like wavelengths of like infinite wavelengths, but there's one peak wavelength that's actually being properly emitted, and it's happening at a certain temperature. And this is basically a relation between the wavelength and the temperature in Kelvin at which it happens, and this leads to a constant which is called the Wien's displacement law. So no matter what, so as you change these ratios, this could go up, this could go down, it still all the time leads to a specific constant which has been derived. And so this is dependent upon the wavelength of that particular light and the temperature at which it occurs. So, and as a reminder again, whatever product, this product has to lead to the same thing, which is the specific constant, and that constant will never change. So that's, I think, the hint to this question. Hopefully this video has helped you in understanding albedo, the greenhouse effect, and has somewhat enhanced your understanding of these topics. I thoroughly suggest that you review the greenhouse effect, because that's, I think, one of the tougher questions, and the climate model diagrams. And although this video did not particularly cover Wien's displacement law and like convection, I thoroughly still suggest that you go over it in your own time. Thank you so much. Hopefully like and subscribe to IB45 or Gone. Thank you.